All right, good afternoon. Thank you everyone for attending today's webinar, Selecting the Right Components for Harsh Environments, brought to you by Gates Corporation and Design World Magazine. Now, just a couple of housekeeping details before we get started. We will be providing you with a copy of this presentation afterwards via email, and we'll also have it online at designworldonline.com. Now, if you wish to tweet about this webinar anytime during or after, you can please use the hashtag that we're all using, which is DWWebinar, all one word. We will have a Q&A session after the presentations, so please go ahead and submit your questions as you think of them, and then I'll go ahead and ask as many of them as I can after the presenters are finished. Questions can be asked using the GoToWebinar dialog box that you'll see there on your screen. All right. My name is Paul Heaney, and I'm the Editorial Director for Design World, as well as the Site Editor for Mobile Hydraulic Tips and Pneumatic Tips, which are some great online resources I hope you're all familiar with. A little background on me. I have a mechanical engineering degree from Georgia Tech, and I've been covering the engineering and manufacturing industries for about 15 years now, and I'm very pleased to be your moderator today. I'd like to take this opportunity to thank our presenters for being here and also to introduce them. Tim Deans is Global Hydraulic Systems Engineering Team Leader for Gates Corp. He has 16 years of experience in product commercialization, project management, application engineering, and customer support. Before joining Gates, where he focuses on fluid power application engineering, new product development, and product commercialization, Tim worked for Toyota Motor Sales USA in various positions at headquarters and in regional positions. He earned his BS in Automotive Technologies from Weber State University in Ogden, Utah. Brett Oman is Manager of Product Application Engineering and Made-to-Order Metals for Gates Corp. In his 28 years of experience, he says he's designed more drives than he can remember. He works closely with marketing and field sales to support customers, commercialize products, and keep Gates at the leading edge. He has supported the design of industrial applications such as conveyors, pumps and fans, as well as more custom solutions, including belt drives for motorcycle companies Harley-Davidson and Yamaha Motorcycle. Brent also led efforts to produce the Design Flex to Go, an automated process which facilitates ease and speed of drive design at customer locations. He has a BS in mechanical engineering from Colorado State University. And now on to our first presenter. Without further ado, I'm going to hand the mic over to Tim. Tim, take it away.
Thanks. Today we're going to be talking about how to select the right products for extreme environments. We're with Gates Corporation, so we'll be talking about belts and hoses, hydraulic hoses, and industrial hoses, as well as industrial belts. One thing to keep in mind is that almost any environment in which you will find belts or hoses can become an extreme environment simply by changing how that piece of equipment is used or the intent of the piece of equipment. So although an automotive belt may have originally been sold on a vehicle in Florida when that individual goes on vacation up to Colorado to go skiing, it's now in an extreme environment. So same with any of our products. We want to make sure that if it becomes an extreme environment and we need to make a change to that product, we know how to do it in a smart manner. So some of the areas we're going to look at are going to be, let's say, the oil field, which is an extremely abusive and aggressive environment. Agriculture, where you'll find access to a lot of different chemicals, agricultural chemicals, spray chemicals, that sort of thing. Mining, which is known for abrasive and crushing forces. Marine, which is primarily salt spray and a lot of corrosive environments for the metals. Food and beverage, which again now we're talking about some more chemicals for cleaning, as well as animal fats. Animal fats have a tendency to swell rubber if you don't use the appropriate type of rubber stocks. And then of course construction, which in any piece of construction equipment might be moved to a new job site where all of a sudden that environment becomes extremely aggressive, and you'll have to change some products so that you can accommodate that. Selecting some of the products will help you eliminate costly downtime. Unscheduled downtime is always the most expensive downtime. We also want to make sure that we are ensuring the safe working environment for not only the person driving the piece of equipment or using the piece of equipment, but those around them. If we rupture a hose, it can spray as much as 10 to 15 feet. So we want to make sure that everyone involved is safe. We also want to reduce and minimize the risk of damage to the components or to the equipment. We want to avoid contamination. So if it's a food-grade hose, industrial hose, we want to make sure that we don't introduce any contaminants or that sort of thing via even a belt that's turning something. We want to make sure that the belt doesn't flake off, get into some sort of food product or that sort of thing. We also want to make sure that we continue to improve the productivity as we go. The Gates products are second to none as far as robustness and quality. People use them for a reason, so the last thing we want to do is have downtime that's associated with that product. So let's start with abrasion. Abrasion is specific to hydraulic systems. Generally, you'll see the cover of the hose abraded. It may expose the wires on the inside of the hose, which are the reinforcement of the hose, and that contains the pressure. Anytime you've abraded the cover and exposed the wires, you've compromised the strength of that hose, and the assembly has to be replaced. Hose abrasion can be caused by routing problems, crushing issues as a piece of equipment moves, or you get articulation that causes rubbing or chopping of the hoses. If they're not routed properly, you can abrade that cover. You'll also start to see some rust and oxidization that will occur when you abrade the cover and the cover is no longer there to protect the reinforcement. At which point, once you've seen red rust, you've got a compromised situation as well, and the hose needs to be replaced. Some of these issues are as easily repaired as simply rerouting the hose. If it's rubbing against something, move it away from what it's rubbing against. So it's fairly easy to fix. If rerouting won't fix it, you can use a extremely abrasion-resistant cover, an ultra-high molecular weight polyethylene sleeve or sheave that we put over it called a Megatough, or you can use something along the lines of a carboxylated nitrile cover in a hydraulic hose, which is what we call an extra tough cover. So you've got options as far as covers that you can use, or you can switch to a sleeve or a metal jacket of some sort that will protect the hose as well. In some occasions, you can even switch to a dual line hose if you've got an envelope where you've got a very tight area that you're trying to fit a group of hoses into. Sometimes a twin line will get a slimmer profile and will stop the chafing as well. Some of the products, again, that come into play as far as abrasion specifically are the Megatough cover, which is the sheathing, the extra tough cover, which is a different type of rubber compound that we make the cover out of, and then of course some dual line hoses, Cordura sleeving, lots of different abrasion resistant sleeves as far as the hoses. For the belts, I'll turn it over to Brent.
Thanks, Tim. So when we're talking about belts, you've basically got the two general categories, synchronous belts and V-belts. This slide's primarily about synchronous belts, but I'll also touch on a couple of items for V-belts as well. For belt drives, when we're talking about issues with abrasion, it's typically one of two things. There's either some very fine particulate matter in the environment that the drive is exposed to, or there's rust present on the sprocket or shift, which creates the particulate matter which wears the belt and the hardware surface. I guess the first question you have to ponder is, how do I know if I've seen too much wear? And it's actually pretty easy for both a synchronous sprocket or a V-belt shiv. A visual inspection, or if you just run your hand in the groove or on the tooth, if you can feel wear or ridge, that hardware is worn and it needs to be replaced. So one of the things to look for on a V-belt shiv is very shiny shiv walls. If they look almost chrome or polished, that shows you right there that it's time to replace those, and there's probably been something in there in that interface that's been buffing the shiv sidewall. One thing I do need to stress is that the abrasive material doesn't necessarily have to feel rough and abrasive to the touch. Just as an example, I was once called to a customer location for a synchronous drive that was running through belts very quickly. It turned out to be that the sprockets were worn. But in this particular case, there was very fine, very small particle PVC powder that was being deposited directly on the belt drive. And even that fine, very smooth powder that almost felt like talcum was enough to rapidly wear through a sprocket. So as far as solutions, what do you do if you've got a wet environment and you're seeing rust? The easiest thing to do is either go with stainless steel or a plated sprocket solution. And in most cases, those are going to be non-stock solutions, but they can certainly be accommodated. And if it's just wear because of the environment, the other thing you can do is to shield the drive as much as possible from that dust and particulate matter. So keep the material away, plate the sprockets, go with stainless steel, and then you can also use products that are tend to be more abrasion resistant, like polychain, which is a very tough polyurethane compound, or for example, the Gates solution on the V-belt side would be a Predator V-belt, and we recommend that for use in very abrasive environments because it's got a very heavy-duty double jacket on the belt, which protects the belt from wear and gives you a little bit more life in those circumstances.
For corrosion, we've got a few different options. Corrosion, we're basically talking about accelerated rust that could occur on any metal components. It can also mean corrosion as in internal, but for the purposes here, we're going to be talking about any kind of chemical breakdown of the metal. So exposure to ag fertilizers, salt spray, road sea salt, UV radiation can break down steel couplings. It can cause red rust. Most of the Gates coupling line uses a mega crimp coupling, which uses our tough coat plating, which is tested at 400 hours of red rust as against the 72 hours of SAE required red rust. So it's a very robust plating to begin with. If you are experiencing red rust too soon on this traditional tough coat plating, there are other things you look at, such as a tough coat extreme, which is specifically made for agricultural chemicals up to and including 32% UAN in your ag sprayers, not only pull behind ag sprayers, but drive through. Drive through are inherently a worse application because you've got more vaporized chemical being sprayed directly on the entire machine. So any of your hydraulic components are going to see a lot more corrosion. In that situation, you would want to move to a tough coat extreme, which is a specifically designed plating for the ag chemical sprayer market. Beyond that, if you had the requirement for salt spray, you've got the option to do stainless steel couplings as well. There's various different things you can do in addition to that that can help you to reduce the rate at which the couplings will start to rust.
As we look at the issue of corrosion with belts, I discussed this a little bit before, but one of the things you have to consider with a belt drive is that corrosion doesn't necessarily only occur if it's in a wet environment. A high humidity environment can promote rust, and you have to consider that most if not all manufacturers' shivs and sprockets aren't treated for longevity in a wet or humid environment to resist rust. Basically, the surface treatment is for storage until the drives are in operation. So if you have a wet environment or a humid environment, even in certain parts of the country where the humidity is very high, rust can be an issue. We've seen that even when shipping products overseas. By the time a shipping container might arrive at its location, if we aren't aware of that ahead of time, you can end up with component parts that are already corroded at the time and they haven't even been in operation yet. So the best way to solve that is just be aware of the environment that the drive is going to be operating in and take the appropriate steps. We do have at Gates, for a specific solution, we do have small 8mm stainless steel polychain sprockets that are standard items, but most of the solution would be a made-to-order non-stock solution, most likely with plating or stainless steel, depending on the speed and the conditions that you're operating in.
Temperature extremes are something that we see quite frequently in both belts and hydraulics. The high temperature extremes will break down the rubber components, and they will leach out plasticizers that keep your hoses soft and pliable and lead to premature failure. Cold weather conditions likely as well will cause cracking of the cover and then expose your reinforcement to the elements, which can rust, and then you'll have a breach as well. So temperature extremes can be both high and low temperature extremes. We tend to focus on the high temperature extremes just because they're the ones that we see the most frequently, but we still want to make sure that we replace it with whichever hose is appropriate. Gates as a manufacturer has extremely low temperature hoses like G2L, which is good to -65 Fahrenheit. We also have high temperature variant hoses which use a CPE tube compound which can handle temperatures up to 300 degrees. So whichever extreme you're looking at, you'll select the hose appropriately for it. Some other products that we have in our industrial line may range from a steam hose, which is inherently going to see an extremely high temperature, which would be a 205 MB hose, or even some barricade fuel lines, which are high temperature fuel lines for the marine application, which at a higher temperature will still meet the permeation requirements required for the marine use on a marine engine. So there's anything that you can think of that you're going to need a hose for, whether it's high temperature or low temperature. There's going to be a product for it. You just need to make sure that you specify which product you're going to need and what your parameters are that you're trying to meet. And when in doubt, as always, call the Gates product application hotline and let somebody help you. Some of the hoses that we're looking at here are some coolant hoses going to a hot oil cooler. Basically, on a hydraulic system, the more work that you perform and the more you try and compress that fluid and cannot, it's going to generate heat. So that heat has to go somewhere, and occasionally you'll have a secondary oil cooler on a machine. The hoses that we're looking at here in the first picture, you'll see that it goes to a Y, and you've got some worm gear clamps that are holding those on. When the machine was looked at, it was starting to weep. The hoses were starting to leak, and the hoses themselves were getting hot enough that they were actually cooked into a configuration where they would not bend. So what we did was we upgraded the hose to the hose that was meant for it. The first picture, they used a off-the-shelf hose product that was not intended for the high temperature. On the second picture, we used a shrink band clamp, which is what's called the constant tension clamp. The hotter it gets, the tighter the clamp shrinks down to. So it continually applies pressure to the hose over the barb to keep it from weeping and leaking. We also put a blue stripe heater hose on the application instead of a generic hose. I believe it was an LOL type product, which was not intended for this high of a temperature and was starting to crystallize and harden and crack and not work the way it was supposed to. So there's different things you can look at as far as replacing the hose, but you also want to make sure that you take into account how that hose attaches. If it's got a sharp barb on a high temperature, you might have a tendency to crack and weep at the coupling. So you want to make sure that you also consider what that hose is going to be attaching to and the type of clamp that you're going to put on it as well, because they will also be very aggressive and in a high temp or a low temp condition can damage the tube, and anytime you damage the tube of a hose, you've opened a breach for the fluids to work themselves to the cover of the hose.
So when we consider the temperature extremes for belt drive, again, whether it's a V-belt or a synchronous belt drive, the main thing you have to be aware of is where is the belt drive going to be used. You might be manufacturing this in Iowa, but your piece of equipment might be used in northern Alaska. So you've got obviously a different set of temperature extremes that you're working with there, as opposed to if the piece of equipment might be shipped to work in the Middle East, for example. So you have to consider both the low and the high temperature ranges of the product that you're applying. And hopefully the manufacturer that you select will have a wide range of temperature capability in the product that you're using. What happens with rubber belts if you run them at too high of a temperature, too high of an ambient temperature, above and beyond their rated temperature, is essentially the rubber compounds continue to cure and they continue to harden, and you will see cracking, for example, like that top picture. You can also see that very similar type of failure if the belt's running at too cold of a temperature, where the material, the rubber material, in effect becomes brittle. So how do you get around that? I mentioned picking the right product for the conditions. So, for example, if I know that this is going to be working on an oil field in a very hot environment with an ambient temperature of 200 degrees, I wouldn't want to select a V-belt and recommend it for that use if that particular belt has an upper temperature range of 140 degrees. So in that extreme example, Gates in particular has a molded notch V-belt. All of our bandless V-belts have a temperature range now of -60 to +230 degrees Fahrenheit. So that's an extremely wide temperature range that will handle all but the very most extreme outlying conditions that you'll run into for a V-belt drive. Similarly, our synchronous belts are rated from -65 to +185 Fahrenheit. We can do some higher temperature constructions in the rubber synchronous belt arena as made to order. But you also need to look and see if there's something you can do on the actual application before you go to a special construction. Some examples of that, just make sure that if this is a very cold environment, for example, if at all possible, when the drive starts up, if it's settling and cold soaking, try to have the drive control set so it doesn't start up under full load. So if you can start the flexing when the belt's very cold, but it's basically just flexing and not transmitting power, that helps the situation. If you can trap any of the heat that might be remaining from the motor or other components that warm, that will help that situation out. As far as the high temperature, just make sure that you don't have a containment area or a belt guard that is so complete that the temperature is basically being trapped in that belt drive or the containment unit. You want to still have some ventilation so that the air is allowed to move through, so you don't build up that temperature and just bake the belt drive components.
All right, let's look at contamination. Contamination in hoses can mean a few different things. We'll break it out, for simplicity, we're going to break it out into industrial hoses and hydraulic hoses. So for the industrial hoses, contamination generally means that we're concerned about imparting something into an ultimate mix. For instance, if I've got a petroleum transfer hose, I don't want to contaminate the petroleum product that I'm transferring, or if I've got an FDA-approved food-grade hose, I definitely don't want to impart any kind of contamination to the food that I'm manufacturing. So industrial hoses, contamination is generally intended for the ultimate product that's being built, and the idea of keeping that contaminant out of the end product. We do things such as using an FDA-approved cleaner between usages of the hose. Whenever we have to disconnect, we want to send a cleaner through it. We clean a lot of our food hoses with steam and water, which we always want to make sure we drain them properly and dry them before we put them back in service, because if you don't, what you can have is trapped water, which can contain germs and contaminants, or under heat you can cause popcorning and damage your hose. Some of these FDA hoses are not very expensive, so we want to make sure we take good care of them. We also want to make sure of what our cleaning is going to be required, what cleaning is going to be required of us depending on what type of industry we're in. Cleaning for transfer of bulk commodities such as flour or something along those lines is going to be vastly different than the cleaning of a food-grade hose in a poultry plant or something where you've got some very serious issues you've got to deal with. So we want to make sure that whichever cleaning solution we use for an industrial hose, it meets with what the end result of the market is going to be that we are in. That may require you to flush the hoses on a regular basis and tag them as clean. and different things like that. So that's the industrial hose side of it. For the hydraulic side of it, we're generally talking about a hose assembly or a new hose assembly that's being installed into a hydraulic system that has a certain cleanliness level, generally dictated by a pump manufacturer or someone who has specified a filter system for that system. You're generally talking about an International Standards Organization 4405, 4406, or 4407 cleanliness standards that you're going to be looking at. 4405 is going to be the weight of the contaminants. I can tell a lot by the weight of a contaminant that I clean out of a hose. If it's heavy and small, I know it's metallic. If it's very large contaminants and light, I know it's rubber in nature or something along those lines. It can give you an idea of what kind of contaminants are in the hose and therefore what you can do to remove those contaminants from the hose. The size distribution, which is 4406, that'll tell me again, if it's large particles, then I know that it's generally rubber, or some cleaning cloths and that sort of thing will also make large particles. And if you're looking through an infrared counter and you have water or particles like that, they'll show as a large particle as well. So you'll know which particles you need to remove and how to do that. The largest sizes, or the particle size and distribution, 4407 is going to help me to identify absolutely which contaminants are the biggest and basically what size filter I'm going to need to get rid of them. So in a hydraulic system, you're going to be taking a different approach in that you're talking about cleaning the hose assemblies before they go onto the hydraulic system and introduce the contaminant into the hydraulic system. So industrial hoses, you don't want to contaminate a food or something that you're going to make that's an end product. But in hydraulics, you're trying not to introduce contaminants that are going to damage your hydraulic system, such as pumps, valves, motors. You don't want it to get contaminant in there that's going to stick a valve or something along those lines. In a hydraulic hose application, if you have contaminants that are rubber or small steel in nature from cutting a hose and manufacturing a hydraulic hose assembly, generally you're going to find those contaminants in an area of slowness in that hydraulic system, say a spool valve or something like that, where the fluid slows just enough that those particles can drop or silt. And you'll find that in sluggish valves, different things like that. That's the kind of thing that you're going to see if you've got a pretty good amount of contamination being introduced from your hydraulic hoses into your hydraulic system. Best way to keep those out is to look at the cleanliness level specified by the manufacturer, and if it's a particular level that they're looking for, you can contact H Product Application and we can tell you what type of cleaning you will need to do to meet that level. Can you do it with shop air, just blowing shop air under compressed air through the hose, or do you need to shoot a pellet or a pig through it? Or do you have to actually hook it up to a flushing machine and flush it until you have certified that assembly to a certain cleanliness level? If you know your cleanliness level, we've got paperwork and we can help you find which one of those methods you're going to need to use to meet the cleanliness level that you're trying to achieve.
So when we're talking about contamination with belting, I think the distinction to make is there's a difference between conveyor type belting or material that's in direct contact with food, for example, compared to power transmission products. Typically, it would be very unusual for any kind of food in the preparation industry to be in contact with a power transmission belt. But the kind of belt that you see in this photograph, the PosiClean, is a urethane belt that's actually designed for that type of environment. So it meets industry standards, and it really, the key problem with contamination on these kind of applications is you have to be able to wash the system down. So the fewer nooks and crannies, cavities that you have that can hold or contain any kind of germs or whatever the contaminant is, the better off you're going to be. So in this case, the PosiClean is a great example of something that fits that because it's a one-piece unit. There aren't multiple joints that are going to be catching that material. So it's very easy to clean, very low maintenance, which also helps reduce your downtime due to the time it takes to clean that system.
Let's look at fluid compatibility. Fluid compatibility is as it refers to hoses. First of all, we'll look at industrial hoses. So obviously we'll look at some food, beverage type hoses. Animal fat is not compatible with most of your tube and your cover compounds for rubber hoses. So you want to make sure that if you're seeing animal fat, you use an appropriate industrial hose. Obviously, steam, any kind of saturated air, that sort of thing, we want to make sure that we take into account and allow for what that has to be compatible with for the industrial hose. For the industrial hoses, not all hoses are alike for fuel either. If you're using a petroleum transfer hose for diesel, it may or may not, it usually will not be compatible with biodiesel. So you want to make sure that you've got a hose that specifies what it will handle. And where do you find that information? It's in the Gates catalog or Gates Online in our compatibility charts, in our industrial hose catalog, as well as our hydraulic hose catalog, is a list of all of our tube stocks and what chemicals they are compatible with. If there's a chemical that has a certain name that is not in that list, you can contact Product Application and we can look that up for you. If you've got an MSDS sheet as well, you can bring that to us and we can tell you if it's going to be compatible. As far as hydraulic hoses, the thing to be careful of is any kind of blend or biodegradable hydraulic fluid. Not all hoses are going to be compatible with that. If it's a nitrile tube stock, which most of the Gates hydraulic hoses are, whether they be spiral or braided hose construction, they're going to be compatible with that biodegradable fluid. However, be careful of blends that are a mixture of biodegradable and different types of fluids. And make sure that you take into account for your high temperature and your low temperature hoses and make sure that they're compatible as well. Because remember, the tube stock changes to allow you to meet different temperature ranges, but it also changes and it changes the fluid compatibility. So you always want to double check and make sure that your hoses are going to be compatible with the fluid that you intend to run through them.
So the issue with belts, when you're exposing them to any fluid, is typically going to be the degradation of the belt's material capability and how long the belt is going to be able to live in that environment. For example, most rubber belts don't like being exposed to solvents or petroleum-based oils, cutting fluids, things like that. The rubber will tend to swell and the belt will delaminate or pull away from the tensile cord. So that's something you want to avoid as much as possible. You can do that by shielding, maybe repositioning the drive so it's not in the direct path of any kind of contaminant. Sometimes it isn't possible, so you have to find the best product that's capable of working in that environment. So for example, Polychain with its polyurethane tensile cord is an excellent choice anytime you've got any kind of cutting fluid or oil in the environment, because the polyurethane is essentially impervious for as far as resisting that kind of contaminant, and it will operate just fine. We've had huge success on those kinds of applications applying the Polychain. It's kind of a dual solution. You not only get the added benefits of the polyurethane, which resists those types of contaminants and fluids, but also the tensile cord is actually encapsulated in the polyurethane. It's not laid up on a layer like a rubber belt would be, so the tensile cords are much more protected, and you don't have the same kind of adhesion issues you would with a rubber belt in those environments.
All right, let's look at some pressures. Hydraulic hoses and industrial hoses. Any hose that you want to talk about is going to be rated at a certain pressure. That's the amount of the pressure that it can contain without rupturing. Hoses and their constructions will dictate differently what the testing requirements are for that. An industrial hose may only meet a 2-to-1 safety factor or burst factor, where hydraulic hoses will meet 4-to-1. So if I've got a 500 psi industrial hose and it's got a 2-to-1, then it will actually burst at and lose a coupling or lose a coupling at about 1,000 psi, and that's to keep the safety factor intact. Hydraulic systems that run much higher pressures and impulse are rated for 4-to-1 safety factor. So 5,000 psi hydraulic hose will actually rupture no less than 20,000 psi. So you want to keep that in mind. Also look at the different applications. If it's a static or a constant pressure flow of the fluid, that's going to be able to handle a higher pressure. For instance, a jack hose. A jack hose is rated to 10,000 psi of static pressure. If it's a dynamic or an impulse wave type pressure, now you're talking about a true dynamic hydraulic type high pressure application, much more aggressive in that the pressure is rising and falling at a very rapid rate, and it's basically hammering on the inside of the hose. So that's why that one carries a 4-to-1 safety factor. We want to make sure that the hoses are going to be used as safely as possible. So when you're looking at extremely high pressure applications, some of the things that you're concerned about, obviously you don't want to have any leaks, but moreover, if it's an extremely high pressure hydraulic type hose, a burst of a hydraulic hose, even if it's only at 180 degrees, which is typical temperature for hydraulics, that's still more than hot enough that if it sprays in someone's eyes or their sinus cavity can cause some severe burns or skin burns. Obviously, we don't want to have any pinhole injection injuries as well. Coupling blow-offs, or if the coupling lets go, now you've got a whip effect of the hose that can act almost like a club and hit people with a steel reinforced hose. So all of these things can cause some extreme damage, in addition to the fact that you're spraying oil all over the place. So if you're a farmer, you're spraying oil all over your crops, and which is not something that we want to have happen. So we want to make sure that we select the right hose for the pressure rating. How do we do that? There are a lot of different places you can look. One would be the schematic on the piece of equipment. If you've got an owner's manual or a service manual for that piece of equipment, you can usually find a schematic in there that will tell you what your pressure relief valve settings are. If your pressure relief valve setting is set at 2850 psi and you use a 3000 psi hose, you're going to be just fine. If it's not in a service manual, a lot of times you can find the pressure relief valve on your hydraulic system itself, and a lot of times it's stamped on that valve what that pressure rating is. So as long as you are going to something that's above that pressure relief, the idea is that the pressure will relieve itself before it maxes out the pressure of the hose. So you can always consult those places. The other thing you can look at is a sleeve, a safety sleeve, such as a Gates Lifeguard sleeve, which will contain a burst or a pinhole up to 5,000 psi. So if you have a hydraulic hose that is prone to having ruptures and you want to protect an operator or somebody around it, there are other products out there that you can put in place. Obviously, the idea is that we'd want to put in the hose that will handle that kind of abuse so that we don't have a rupture. Some other things we can look at are if you've got flex fatigue at high pressure, there are products such as the Million Impulse Cycle braided hose, which is much more flexible than a spiral hose. So at 4,000 psi, instead of having to use an S8100 R12 spiral hose that's not flexible at all, it's basically a somewhat flexible pipe, rubber pipe, we can use a extremely flexible Million Impulse Cycle braided hose, which allows the hose to flex and move at 4,000 psi and perform just like an SA100 or 12 spiral hose, only be much more flexible, less prone to cracking and cover fatigue. So there's lots of different options out there for high pressure hoses in hydraulics.
So one of the issues with belt drives is operation in a hazardous environment. And in particular, what I'd like to discuss is if you've got an explosive environment, any kind of environment where you don't want to introduce a spark. Now, if you probably already know if you've got an environment that's like that, but there are some environments that would surprise you. So basically, if you've got a contained area with dust that's airborne, that is more than likely going to be an environment that you need to really be aware of and take steps to make sure that there's no chance of spark with any kind of resulting fire or explosion. So how do you do that? This is kind of the old belt and suspenders solution. Obviously, you want to make sure that you're using a static conductive belt. And when we define a static conductive belt, that just means that the belt material itself, the belt acts as an electrical conductor. it will conduct a charge through to the sheaves or the sprockets on into the shaft and through the whole system until it's grounded. What you want to do is try to keep the belts clean in that case, so that you don't interfere with the conductive interface between the belt and the surface of the hardware. And also make sure that you have the systems grounded properly. Always make sure if it's an extremely serious condition, or you're unsure of the situation, you can use a grounding brush to bleed the charge off to ground. Usually those are just brushes that are in contact with the back of the belt. So as far as recommended products, any of our, at Gates, any of our heavy-duty V-belt lines are static conductive, as are our 8 and 14 millimeter pitch power grip GT2 belt lines. And that's something to check for. It's much more common in industry now, but it is something to just verify with your belt manufacturer that you don't want to overlook and have to deal with the consequences later. So I guess we're to our last slide. Just as a wrap-up here, we've gone through a ton of material and a lot of details. So the main thing we want to leave you with before we get on to any questions that might have been asked is, really what you want to do is consider the environment that the drives are going to be working in, or the hose and hydraulic systems are going to be operating in, and make sure you do your research and pick the components that will work best in that system. Don't make assumptions that the system will only be in a certain environment, because inevitably it will end up being in a more challenging environment than you would probably originally guess. And the key to that is by selecting the right components and being aware of things that you can tweak in the system to account for some special considerations, is you can greatly diminish your downtime, increase your uptime, and your throughput and productivity. And that's the main function of all of these hose, hydraulic, and belt systems, is to ensure that productivity is at the highest level possible. We don't want to see problems or hear problems with our products at customers, and we want you all to be running as effectively and efficiently as possible. So with that, I guess we're through our prepared material, and Paul, I guess I'll turn it back to you for any questions.
Well, thank you very much, and great information, both you gentlemen, and we appreciate your taking the time here. We are going to go in the Q&A session now. As a reminder, there is a little box in your GoToWebinar screen there where you can type in questions, type them in, and we will answer the ones that we can. And it is not too late, so please get your thinking caps on there. First question, and this is not oriented to anyone in particular. It says, if I'm using a hose designed for high pressure, do I also need a sleeving system? And if so, what type of sleeving is best?
It's going to depend on a few things. For the hoses, let's look at industrial hoses first. If it's an industrial hose, a lot of times they'll put a sleeve on it for various reasons. If it's an industrial hose that's exposed to a high temperature environment, there's silicone-based sleeves that can handle intermittent contact up to 2,000 degrees. So if that's the case, yes, put a sleeve on to protect the hose. If you're more worried about operator injury or contamination of a food product or something along those lines, I would caution, if it's a food product, always want to make sure that the FDA is going to sign off on that, because anytime you put a sleeve over a hose, you can trap contaminants and germs and that sort of thing in there. If it's a hydraulic hose, you want to consider what the sleeve would do. If it's for a chafing or an abrasion resistant situation, then you can use a Cordura or a nylon sleeve. If you need lightweight, or you can use actual metal spring guards if it's an extremely abrasive or crushing type component. If it is for operator protection, in other words, if it's within 3 feet of the operator area and it's a hydraulic hose, then it would have to be a certified SAE safety sleeve that would go over that hose. So you want to make sure which sleeve you're putting on in each application.
Gotcha, that makes sense. Another question that just came in. I've tightened a squealing belt several times and corrected tensioning, but the squeal keeps returning. What could the problem be? Is it a solvent or an issue with the load?
Well, I guess it depends on the circumstance. If the person asking the question is asking if it's a solvent, I would assume then that they probably have something that's hitting the belt and the sheave. So that will sometimes quiet a squeal, and it will make you think that is running okay just because you don't get the squeal from the V-slip. That's often a way that you troubleshoot a belt from, is just to squirt some water or some soap into an interface, see if it changes that noise that you're hearing. So I would suspect in this case, if you're still getting a squealing sound, it's probably not from a solvent, but it's probably most likely just that you just don't have the belt tension high enough. So we provide belt recommendations either through our product application group or our online design programs. It's very easy to calculate belt tensions. We have a phone app that will calculate belt tensions. So the general guideline is if it squeals, tighten it up. You're probably not going to over tighten it. The other thing to look for is if you just can't seem to get the squeal to go away, inspect the hardware. It could very well be that no matter how much tension you put in that system, if the V-belt groove is worn, the sidewalls aren't going to seat properly, and it's going to slip no matter what you do. So look at the whole thing as a system and not just as a belt by itself.
All right. Next question, do reinforced belts promote galvanic corrosion when used with aluminum pulleys?
No. Because the reinforcement for power transmission belts is are flexible fibers, usually fiberglass, maybe aramid, in some cases carbon fiber. So we regularly use aluminum sprockets in situations where lightweight is a concern. One further thing about aluminum sprockets is in a lot of cases, if it's a heavy-duty application, you're going to want to put some kind of a hard-coated plating on that surface just to help with the wear, to extend the belt life, the hardware life as long as possible.
Okay. This user says that they are noticing blistering in their hydraulic hose. Is it probably caused by a bad hose? What could have caused this? And if the blistering is minor, do I need to replace the hose?
Blistering can come from a couple different areas. One, it can more than likely it comes from air in the system. Where does the air come from in the system? If you've got a lot of condensation, as that temperature, as the hydraulic system heats up and cools down, you'll break down the water into some air molecules that will get pushed through the tube stock of the hose, and you'll see a blister on the cover of the hose. One thing to do is first depressurize the system so that the hose doesn't have any pressure on it, and pop the bubble. See what's in the bubble. If it's air, you know that you've probably got some water that's getting into your system. You may have a desiccant breather cap or something like that that's reached its capacity or something, and it needs to be replaced. But if it's air, you need to chase it down and find out where the source of the air is coming from, or moisture in your system. If it's oil in the blister, that means you've got a breach of the tube, and the actual fluid is coming through the tube, through the reinforcement, and it's bubbling up under the cover. If that's the case, you absolutely should replace the hose immediately, but moreover, you want to find out how that is occurring. So if you've got multiple blisters across the cover of that hose, you might look at your fluid, make sure that your fluid's compatible, especially if you know that you're using a blend or a biodegradable fluid. That's the first thing to suspect. Beyond that, you might start to look at some temperatures or some other issues that might start causing some issues as far as the rate at which that fluid can pass through that tube, or if it's an extremely hot situation, you may need to upgrade to a high temperature hose to maintain the integrity of the hose.
Okay, great advice. Following question. I work in an extremely cold environment and experience premature failure due to belt cracking even when I choose cold weather belts. What can I do next?
Well, I guess it depends on what the capability of the belts are that you mentioned as cold weather belts. Some general constructions might only be able to get down to minus 40 or so Fahrenheit. For example, our bandless V-belts can get down to minus 60. Our synchronous belts, because they're a thinner cross-section, can actually operate down to minus 65. So select a belt line that can get you down to that low temperature. And as I discussed during the presentation, try, if at all possible, if this system turns off and on, if it's off for any period of time and there's a cold soak situation where the drive gets very cold and it's sitting at that cold temperature, when it does have to start up to operate, hopefully you can start that up, ramp it up to speed slowly, or at least control the load so that the load isn't applied immediately. So obviously if you've got something like a variable frequency controller in the system and you can control the startup, that's an ideal situation, and you can really extend your belt life just by controlling that startup condition. Because once the belt starts to flex under operation, even if it's in an extremely cold environment, it generates its own internal temperature, and it almost acts like its own heater in those conditions.
Okay. Next question, and we still have time for just a couple more, so if you have any questions, please type them in. How is ozone attack on belt polymers best addressed?
Well, ideally, the best way to do it is shield the belt. In some circumstances, that's not going to be possible. Obviously, if it's operating outdoors, there's ozone exposure, or if it's located close to a motor, which unfortunately most belt drives are located very close to an electric motor. So really what you want to do is you want to have a belt that's constructed using the high-quality rubber components that are resistant to ozone. For example, our EPDM construction is very resistant to ozone, as is the polyurethane construction of polychain.
All right, let's have one more question here. Viewer says, regarding squealing with synchronous timing belts and pulleys, can you please discuss side squeal per the right-hand rule of torque generating side loads, and how do you get the belt to stop squealing?
So when the questioner talks about the right-hand rule, I'm assuming he's mentioning the cord twist. So many years ago, synchronous belts didn't used to have tensile cords that were alternating twist. So they would have cords all of one twist or of another twist. And depending on the direction of the cord twist, the belt would travel in that direction. That's what the right-hand rule gets to. So if you put your hand in the direction of rotation, your fingers in the direction of rotation, if it's an S twist tensile cord, it would travel in the direction of your thumb. And if you use your left hand for a Z twist, it would go in the opposite direction that your thumb is pointing. Modern synchronous belts use alternating neutral cord twists, so that's usually not a problem. A synchronous belt will tend to travel in one direction or another. It's not going to be perfectly neutral tracking. So if you notice it running up hard against a flange on the sprocket, there's probably some misalignment. And it might not be static misalignment that you can measure when the system's not operating, but if you see it during operation, that tells you that there's some deflection occurring while the system's under load. So the best thing I can recommend is to, it's going to be a little bit of a trial and error method, so you might have to statically introduce a little misalignment so that dynamically when the load's applied, the system is running in an aligned position. And that misalignment is usually just created by shaft deflection or system movement.
Gotcha. All right. Well, we're coming up on our hour here, so that's all the questions we have time for. Thank you again, Brent and Tim. For all the questions that come in afterwards, Gates will be answering them individually via email. So if you have additional questions that come to mind, you are most welcome to email those to me at pheeney@wtwhmedia.com, and I will be happy to pass them along. Thank you, everyone, for attending this webinar from Design World and Gates Corp. And thanks once again to Brent and Tim for speaking today. As I mentioned earlier, this presentation will be emailed to everyone in the coming days, and in the coming days, it will also be available online at www.designworldonline.com. Have a great rest of your day. Goodbye.